Hello everyone, welcome back. Today we're going to do a video on the topic of microcontrollers. The topic is peripheral devices in embedded systems. Peripherals. Embedded systems that interact with the outside world need some form of peripheral devices. A peripheral device performs input and output functions for the chip by connecting to other devices or sensors that are off chip. Each peripheral device usually performs a single function that may reside on chip. Peripherals range from a simple serial communication device to a more complex 800 or 2.11 wireless device. All ARM peripherals are memory mapped. The programming interface is a set of memory address registers. The address of these registers is an offset from a specific file base address. Controllers are specialized peripherals that implement higher levels of functionality within an embedded system. Two important types of controllers are memory controllers and interrupt controllers. Memory controllers. Memory controllers connect different types of memory to the processor bus. On power up, a memory controller is configured in hardware to allow certain memory devices to be active. These memory devices allow the initialization code to be executed. Some memory devices must be set up by software. For example, when using RAM, you first have to set up the memory timing and refresh rate before it can be accessed. Interrupt controllers. When a peripheral or device requires attention, it raises an interrupt to the processor. An interrupt controller provides a programmable governing policy that allows software to determine which peripheral or device can interrupt the processor at any specific time by setting the appropriate bits in the interrupt controller register. There are two types of interrupt controller available for the ARM processor: the standard interrupt controller and the vector interrupt controller. The standard interrupt controller sends an interrupt signal to the processor core when an external device requests servicing. It can be programmed to ignore or mask an individual device or set of devices. The interrupt handler determines which device requires servicing by reading a device bitmap register in the interrupt controller. The vector interrupt controller (VIC) is more powerful than the standard interrupt controller because it prioritizes interrupt and simplifies determination of which device caused the interrupt. Depending on the type, the VIC will either call the standard interrupt, except handler. Types of peripheral devices. Peripheral devices can be broadly categorized into two types of based on their location. On-chip peripherals. Integrated on the same chip as the processor. Examples are timers, control counters, ADC, which is analog to digital converters, DAC, digital to analog converters, GPIO, general purpose input output pins. Advantages: they have faster access, lower power consumption, and reduced cost. The second type is an off-chip peripheral. External to the main processor chip, connected via communication interfaces. Examples are external memory, sensors, displays, communication, Wi-Fi or Bluetooth storage devices. Advantages: greater flexibility, easier to upgrade or replace, specialized functionality. So in conclusion, peripheral devices are integral to the functionality of embedded system, providing essential interfaces for input-output, communication, and memory management. Understanding the types and functions of these peripherals, as well as how to program and interface with them, is crucial for designing effective embedded systems. ARM-based systems with their memory map peripheral architecture offer a flexible and powerful platform for integrating a wide range of peripheral devices. Thank you for watching.